Hello, students. In this lesson, we will learn about the construction and inspection of sunken green spaces. From previous lessons, we know that sunken green spaces are green areas lower than the surrounding pavement or roads, by less than 200 millimeters. They are widely used in buildings, communities, roads, green spaces, and squares. The structure of a sunken green space, from top to bottom, generally includes a super-elevation water storage layer and planting soil layer. If the permeable surface at the bottom of the sunken green space is less than 1 meter from the seasonal highest groundwater level, or the facility from the building foundation is less than 3 meters horizontally, or located in a road green belt, near the roadbed, an impermeable layer must be installed. Sunken green spaces also include inlets, overflow wells, and other facilities. For areas with severe runoff pollution, pre-treatment facilities are also required. Now, let's look at the general rules for the construction of sunken green spaces. Before construction, relevant drawings and documents should be reviewed to identify the underground pipelines or hidden objects in the area. This avoids damage to pipelines or hidden objects during construction. 2. Before excavation, filling, or compaction, a site survey should be conducted. For example, data on the permeability of surface soil in infiltration areas and groundwater levels should be collected before construction. This helps in choosing construction methods and preparing project and safety plans. During construction, natural soil permeability should not be reduced. 3. Raw materials, semi-finished products, and components, before entering the construction site, must be inspected and accepted according to relevant requirements. For that in the early stage of microtopography construction, in sunken green spaces, in order to prevent soil erosion by rainwater, soil conservation measures should be implemented to prevent soil from entering the rainwater system and blocking the network. The sunken green spaces can be inspected based on their ability to store and purify runoff rainwater. The area and volume should meet or exceed design requirements, and the shape can be adjusted based on the terrain. The construction method of sunken green spaces should meet design requirements. Next, let's learn the construction process of sunken green spaces. The construction process should be reasonably determined based on the facility structure and site conditions. The general steps are preparation and surveying, earthwork, then construction of inlet and drainage facilities, followed by microtopography construction, soil backfilling, and planting. First, let's look at the preparation and measurement layout. Sunken green spaces should start construction after the completion of the catchment surface. According to the design, mark the edges of the sunken green space. For straight sections, mark every 20 meters. For curved sections, every 10 meters. Ensure the protection of control stakes, and use stakes if needed. Mark excavation lines with wet line. According to the design trench base elevation, determine excavation depth if existing pipelines are encountered during layout. After obtaining consent from the design unit, the position or shape of the sunken green space may be adjusted to avoid the pipelines. If space is limited and pipelines must cross the sunken green space, the design unit should be notified to implement protective measures. Avoid damaging the pipelines during excavation. Earthwork construction. Excavation should be done manually in combination with machinery. Above the design trench base elevation, leave a soil layer of 5 to 10 centimeters. Then use manual excavation to reach the designed trench depth. This avoids over-excavation and disturbance of natural soil. When excavating trenches for sunken growing species, ensure bottom drainage and prevent surface water entry by setting an open drainage ditch at the top of the pit. This blocks external water from entering a pit. After trench excavation, around the perimeter or reserve inlets, set temporary barriers to prevent soil erosion. This prevents soil collapse into the trench, maintaining the depth and permeability of the sunken green space. For unstable trench slopes, additional support should be installed from the trench edge, topsoil at least 0.8 meters away. With a height not exceeding 1.5 meters, monitor trench slopes on site and ensure a safety passage. Set up safety signs and perimeter protection. Next, let's look at the installation of the impermeable geotextile. The quality of the impermeable layer material directly affects the project quality. Near the roadbed or buildings, according to design requirements, when geotextiles or geomembranes are required, their performance and size must meet design specification. What are the material requirements for the geotextile? Impermeable geotextile can serve as a protective layer for the membrane and as a filtration and drainage material. As shown, it should have good mechanical properties and high permeability and be resistant to corrosion and aging, with functions such as separation, filtration, drainage, protection, stabilization, and reinforcement. After arriving on site, geotextiles should be stored in a ventilated, shaded warehouse. They must not be exposed to sunlight. For the appearance quality of geotextiles, the reference standards are as follows. The material should be black, with no visible watermarks, haze, or mechanical scratches. It should have no holes, bubbles, or thin spots, and the cut should be straight. Next, before laying the impermeable geotextile, let's look at the requirements for preparing the support layer. First, the surface of the support layer must be smooth. It should be free of roots, debris, stones, rebar ends, and glass shards. The surface should also be dry before installing the geotextile. Approval from the supervising engineer is required. Let's look at the method for laying the impermeable geotextile. First, the geotextile material should have a relatively high weight. It is best to use loading machinery for transport and laying. For roadsides, since the geotextile should be parallel to the road center line. On slopes, the laying direction should follow the slope. It is recommended to lay the entire row on slopes. Without horizontal seams, the geotextile should not be stretched tightly by temperature changes and backfilling, allowing room for expansion and contraction cost. How should the geotextile be overlapped? As shown in the diagram, the overlap width between seams should not be less than 100 millimeters. Ensure that the geotextile fully covers the support layer, without any gaps. Process requirements. The support layer should be rechecked before laying the geotextile. It must be smooth and free of stones, roots, or other sharp objects. During transportation and installation of the geotextile, avoid vibration and impact. It is best to install it in one go. When laying the geotextile, the membrane side should face up. Finally, let's look at the precautions for installing the geotextile. Outdoor work should be done when the temperature is between 5 to 40 C, and the wind force is below level 4, and there should be no rain or snow. Before cutting the geotextile, measure the size, then cut, number each piece, and keep records. When laying, avoid creating artificial wrinkles in the geotextile. Smoking is not allowed at the installation site, and no spike shoes or hot sole high heels should be worn on the membrane. No activities that could damage the membrane are permitted. The geotextile should be laid loosely and adhere to the support layer, without folds or being suspended. During laying, inspect for any damage, watermarks, spots, holes, or creases. Replace any defective products immediately. The above is the construction process for the geotextile. Next, let's learn the construction of the gravel and medium coarse sand bedding layers. The material requirements are as follows. Gravel should be tough, durable, and have good permeability with proper grading. For example, crushed granite or limestone. Different hardness materials should not be mixed. No one should single-size stones, shell, or weathered stones be used. Gravel should have multiple angular shapes, be clean, soil-free, and contain no stone dust or weather impurities. The specification and quality of medium coarse sand must meet design and regulatory standards. Overall, the mud content should not exceed 5%. The operating conditions are as follows. Set markers for controlling fill thickness, such as elevation stacks. On the pit slopes, install horizontal wooden stacks to serve as elevation markers. Implement effective dithering measures during construction to keep the pit dry. Next, let's look at the bedding layer placement. After geotextile installation, promptly lay the gravel and medium coarse sand bedding layers. After the gravel is delivered and spread at the site, particles should be evenly distributed. Spread to the design thickness in one go, following the principle of transporting and laying from far to near. Material should be divided and stacked according to pre-calculated quantities. Use both manual labor and machinery for placement. As shown, the gravel should be uniformly graded, with no obvious particles apart. Do not use 4-tooth rakes or similar tools. That can cause localized concentration of coarse or fine materials. Any concentration of coarse or fine materials during placement should be promptly corrected. Next, let's review the backfilling of planting soil. First, the requirements for planting soil. It should meet standards for salinity and pH, be loose in texture, have a granular structure, and possess adequate fertility. Typically, it is topsoil from a depth of over 80 centimeters. Sandy soil with good drainage is preferred for planting. Otherwise, heavy clay soil with poor aeration and permeability can compact after watering and inhibit plant growth. Now, let's look at the process of backfilling planting soil. Before backfilling, remove any debris from the base soil and thoroughly inspect the soil quality. Check the type, particle size, and presence of debris in the backfill soil. The moisture content of the soil should be within the design range. Planting soil should be backfilled in layers, with each layer's thickness determined by soil type, compaction requirements, and equipment capacity. Heavy machinery compaction should be avoided to maintain natural soil permeability. For compacted soil, measures should be taken to improve its density, while ensuring that its permeability meets design and regulatory requirements. Next, let's review the construction of inlets and overflow wells. First, the location of the inlet with a completed catchment surface should be adjusted based on the actual runoff path in water accumulation areas. Inlets should be distributed along the ditch length, and open channels should be used for drainage. When curbstones surround sunken green spaces, they are usually perforated to allow rainwater from the road surface to enter the sunken green spec. Add concentrated rainwater inlets in sunken green spaces, and add upfalls of steep filtration measures. Measures such as placing pebbles, energy dissipators, geotextiles, or planting permanent vegetation should be used to reduce energy. The purpose is to prevent water flow from damaging the sunken green space. If the design is unclear, pebbles with a diameter of 100 to 200 millimeters are recommended as energy dissipation measures for water flow. The layout width should be around 1000 millimeters. The connection of the sunken green space to its surroundings should meet design requirements. If not specified, a gentle slope can be used. The slope of the embankment should not exceed 1 to 3. Other slope protection forms should meet stability requirements. Overflow wells are a critical part of sunken green spaces. They transfer rainwater overflow to the municipal drainage system to ensure normal operation. Thus, the location, depth, and spacing of overflow inlets should meet design requirements. Installation should be straightforward. Additionally, the construction of filtration overflow facilities should comply with design requirements, and the water supply and drainage pipeline construction and acceptance code. Next, let's learn about plant planting. Plants chosen for sunken green spaces should be local species that are drought-tolerant, water-resistant, and resistant to stagnation. They should have well-developed root systems and strong purification capabilities. They should provide initial purification of pollutants carried by rainwater. There should be sufficient base fertilizer under the plant roots to prevent rainwater from washing away nutrients in a short time. Planting requirements should meet horticultural standards. The above is the construction process and main methods for sunken green spaces. Next, let's learn the acceptance process for sunken green spaces. The construction acceptance of sunken green spaces should be organized by the construction unit, jointly with design, construction, supervision, and relevant units. Check whether all parts of the project are complete, and if supporting facilities are reasonably arranged. Acceptance can be done using a comprehensive evaluation method, according to the Sponge City Infrastructure Construction and Quality Acceptance Standards. Acceptance items are generally divided into primary control items and general items. First, let's review the primary control items for sunken green space acceptance. The construction form of sunken green spaces must meet design requirements and should not cause secondary disasters in surrounding areas. The planting soil and filtration materials used must not contaminate soil or water. The inspection methods include visual checks and steel tape measurements, and verifying factory certificates and quality inspection reports. Second, the depression depth of the sunken green space should be lower than the surrounding pavement or road, and the height of the water storage layers should meet design requirements. If not specified, it should be controlled between 100 to 200 millimeters. It is recommended to inspect for points every 200 meters. Inspection methods include visual checks and steel tape measurements. The elevation of overflow outlets within the sunken green space should meet design requirements. If not specified, it should be 100 millimeters below the surrounding pavement or road, and 100 millimeters above the green space base. The inspection frequency should be a full count. Inspection methods include visual checks, steel tape measurements, or leveling instrument measurements. for acceptance of planting soil, terrain engineering, plant material engineering, and planting works. The primary control items should comply with the landscape engineering construction and acceptance code. Inspection methods include visual checks and soil sampling for pH testing. Next, let's review the general items for sunken green space acceptance, the species specification, and planting density of plants in sunken green spaces should meet design requirements. The inspection frequency should also be a full count. Inspection methods include visual checks and steel tape measurements, pest and disease control for plants in sunken green spaces, should use biological and physical methods, and the use of chemicals is strictly prohibited too. Avoid contaminating water sources. Inspection methods include reviewing construction plans, on-site pest control measures, and construction laws. For acceptance of planting soil, terrain engineering, plant material engineering, and planting works, general items should comply with the landscape engineering construction and acceptance code. The area of sunken green spaces should not be less than the design requirements. The inspection frequency should be a full count. Inspection methods include instrument measurements or steel tape measurements. In this lesson, we mainly covered the general construction regulations, construction process, and primary methods for sunken green spaces, including detailed instructions on installing impermeable geotextiles and the acceptance items for sunken green spaces, divided into primary control and general items, including inspection frequency and methods. That's all for this lesson. Goodbye, everyone.